Good morning, everyone. My name is Viktor Egorov. I work in Data Egret company as administrator, and I've been working for many years with PostgreSQL, and I also worked with Oracle databases. And I would like to talk about the architecture of those two SQLs and to better understand the similarities and also the differences. I will not be able to overview the architecture as a whole. We will just touch on the main components, and hopefully it will be a starting point for your future studies of literature and official documentation. These are just a few books which I use in my work, and you can use them as well. I recommend this literature. So what we will talk about? First, general overview, because I think that these SQLs are quite similar, and then we will review the creation of databases, the structure, the processes, the memory, redo and undo, and also backup and replications. So approximately this is the sequence of our presentation. So what are the similarities? They are both ACID compatible, so they support transactions and sustainability. You can be sure that you will not lose any transactions which were committed, and also ACID support is related to how the other mechanisms in the database will be implemented. For example, data protection. Both those databases are built on version engines. They both support backup and replication, and they both are SQL compatible. If you worked with one of the databases, it will be easy for you to switch to another. You will always feel the similarities of these databases, but also, of course, there are differences, and this is what I would like to talk about today. Let's start with creation of databases in Oracle. This is quite a lengthy procedure. You need to write a lot of configuration files to set up the environment, and then you can connect and create the database. And in create database statement, you need to indicate absolutely all required table areas, redo, memory parameters, etc. This is quite a complicated script if you will write it manually. This is why a lot of utilities exist, which will enable you to do it in a more convenient way, using the GUI or scripts. Or you can do it yourself, if this is the only possibility. And if we compare how the databases are created, from my point of view, Postgres is better because you just need to execute initDB utility and it will indicate the location, and then just edit the PostgreSQL config file, and then you can start it and work with it. You can correct parameters, you can create new tables, new databases. It also supports multi-tenant installation, so it can support several databases. Both databases support table areas, and both databases, when you create a copy, they ask you to indicate the location where the system part of the database will be located. In Oracle, it's system and sysaux table spaces. And you must indicate this location when you create a copy. This is similar. The file with data exists only in Oracle. Actually, they exist in both databases, but in Oracle, administrator can operate these files. And in Postgres, you don't have such a possibility, and the database works with tables itself. Postgres works with file system only, and Oracle can work with ROI devices and direct I/O mode. With normal data files, Postgres cannot work in this manner. So this is a big difference. And I hear sometimes recommendations to add direct I/O support on Postgres. This is how it looks on the drive when you create a copy. In Oracle, we see, in this case, 6 data files, and each one is related to its table space. And this is what you see when you create a database. All these segments are inside those data files. In Postgres, the structure is quite big, and each segment is related to one file on the drive. Here we created an empty database, and it already has 800 files. This is how Postgres works. It's not good or bad, it's just the way it is, and you just need to consider that in your work. A bit more about physical storage of data. Segment is an area on the drive which is related to an object in the database, which should be stored on the drive. It can be a table, index, some presentation, glob, or other table in Postgres. This is all indicated by segment, and it's related to a certain part on the disk. And Oracle stores the files inside. Extends, it's not convenient to allocate storage in little segment, so this is why Postgres, starting from version 9.6, can allocate big areas of space on the drive. And I think that this is a good new feature, because before we had problems when there are a lot of inserts in the table, and databases could start to be slower because it had to add additional segments. Both databases use 8 kilobyte blocks. This is something which is read from the drive, and also block is stored in the cache of the database. A big difference, Oracle blocks can be adjusted, and if you want to create database with block size 16 or 32 kilobytes, you can do it in Postgres as well, but you will have to recompile the initial files. But this is not a common practice. Usually everyone just uses 8 kilobytes. This is a little example from Oracle. This is table space user, data file, and you can see the green blocks which are related to different segments, departments, employees, organizations, and each segment represent section with extents with different number of blocks. First one contains 4 blocks, next one more than 4. So the space is allocated in such segments. And within one data file, some empty space can exist. This is called fragmentation. So when you compress the file, this space will be compressed. A similar problem exists in Postgres as well, and we will talk about it now. This is the low physical level, the structure of a block. There are many differences. Any block, in addition to information, contains also headers. This is working information, and overheads can be up to 107 bytes as per the documentation. And this includes also headers. Overall, overhead are much less. It's 24 bytes for the header and 4 bytes for each entry. So the header is in the beginning of the block. In yellow you can see the table with entries, and the empty space is always somewhere in the middle in the block. But in Oracle, in the free space, also a table with transaction is contained. And accordingly, this space is reserved from the beginning in advance, and competition access to this block is limited, so other sessions will have to wait. Also, a big difference is that one block can store data from different tables. In Postgres, it's not possible. And between the headers and the table with indexes, there is a list of tables which are contained in this block. Let's talk about the entries. The structure of entry is in Postgres. This is another header which is 23 bytes, and after which a null mask happens. In Oracle, the header is much less. It's just 3 bytes, and overheads of Oracle are much less. There is no null mask in Oracle, which means that on the physical level, Oracle cannot distinguish null line and empty line. They are stored in the same way. And sometimes people who worked with Oracle, when they move to Postgres, they cannot understand why the database reacts differently to empty lines and null lines. Both Oracle and Postgres starting from the version 8.3 and Oracle starting from version 7, they froze the structure of block and entry, and since then it didn't change, and it enables us to upgrade the database quickly without rewriting of the whole database. And this significantly makes the process much faster, and both databases are similar. So if you need to add additional features or functions, then the further upgrade can be much more difficult. Versions. Postgres ensures versions on the level of entries and Postgres on the level of the whole block. This is the difference, and this is why the header of entry in Postgres is so big, because it contains information about the version. And in Postgres, none of the entries cannot be more than the size of the block. In order to achieve that, every time when you create a table which has lines with variables, the database will create automatically a special system of tables where all those long entries which are not fit in the block are stored separately. And Oracle can store the long entries in the chains of blocks up to 1 gigabyte. And if in Oracle you have a table with huge number of columns, and your scan will take more time if you choose certain columns. It will have to scan the chains anyway. In Postgres, it's a bit easier to scan the whole table. Processes. We're going back up a little bit. So we created a database. We look at the process started. By default, only 6 processes started. Stats collector, auto vacuum, wall writer, and check pointer. With Oracle, there is much more processes, and it depends on the number of options enabled, and Oracle doesn't have a tree structure. They just exist independently from one another. And from the monitor you can look which processes are present in the system. This table gives a comparison of different functions in Oracle and Postgres. Important difference in Oracle: all blocks are written on the drive by DB writer. And in Postgres, 3 processes are responsible for this function. And unfortunately, individual sessions can write blocks on the disks either. So if you have a read request to the database, it needs to read something from disk. And if the block is dirty, then your read request will actually be able to write data on the drive. Unfortunately, this is the architecture. Parallel workers in Postgres don't exist. They are run when necessary, and they disappear after some time. Sessions. Every database realizes a model in which every client connection is a separate process, which means that in the database a separate process will be created and maintained. And if you have a web server and session time is limited, but there are many connections, the load will be very high because many sessions will be created, which is not good. In Oracle, you can build shared servers. In Postgres, it's better to use PG bouncer. This is how it looks like. The simplest process when you have one client, it connects to the database, and a separate server process is created with one session which works with the database. This is the most simple option. Or PG bouncer and separate server process, several clients are connected to the database and they are all served by one process, and each session is served individually by one process. Third option, only Oracle have. When you have just one client connection and one server process, and within this process 2 independent sessions exist. And when you make a request, this is what happens. Your request works in one session, and auto-trace is created within the framework of the same process, but they work independently and they do not affect the operation of your request. And this is the mechanism which is used for autonomous procedures. Within one process, there are two independent sessions and independent transactions which can coexist together. This is quite a convenient function which maybe should appear in Postgres as well. Distributed memory. This is where all the information of the database is stored, which enables us to access the data fast and conveniently. And there are many differences. In Postgres, 97% of the memory are shared buffers, and the other 3% are service structures which are necessary for management. In Oracle, the distribution is not that big. You can see in green buffer cache in Oracle, and percentage is much less from the total in Oracle. And Oracle has other very important structure which is called shared pool. In Postgres, there is no such structure. In addition to cache of the main pages, Postgres also stores processes, blocks, cache logs, and background processes and statistics. And very important difference from Oracle is that Postgres is always reading all the information from the drives via shared buffer. And user's request cannot be read from the drive. It never happens. If you want to read more in detail about shared memory, I recommend the presentation of Bruce Momjan inside PostgreSQL shared memory. Talking about Oracle, they call big portions of shared memory pools, and shared pool is very important. The pool stores the plans of your requests, the procedure codes, and this is a very critical area. And this is where the difference comes from between Postgres and Oracle. In Oracle, if you execute a request for the first time, it goes to the shared pool. And then every session, regardless is it yours or somebody else's, it executes the same request. Oracle finds it in the shared pool and uses the plan which has been used before. So when you make planning once for this request, it then can be used for the future requests as well. In Postgres, the plan will be stored only for your session. Plus is that if requests are big and they are planned just once, and then this plan can be used further, depending on the complexity of the structure, you can maybe go faster by a few milliseconds. But if something goes wrong, statistics is wrong, for example, something else, and some disadvantageous plan has been fixed in the shared pool, everybody will suffer from it. And Oracle also can read data directly from the drive, and Oracle also can work with blocks of different sizes. Because in the version 12, they added multi-tenant option. One sample can connect databases with 4 kilobyte blocks, with 32 kilobytes blocks, and it will work just fine within the same sample. Process global area. This is the term from Oracle. It doesn't mean that a shared piece of memory is used for all sessions. This is a recommended limitation, and Oracle is trying to support the individual memory for all sessions, not higher than a certain limit. But sometimes one session can request, for example, a lot of memory. It can be given to it, but everybody who will come after and request for memory, they will be given either very small portions or maybe even denied completely from memory. Postgres doesn't have anything like that, and this is a headache of database administrator to not allow to a database to get more memory than it needs, because if swapping starts, the requests will be very slow. This is a very interesting feature, redo. In Postgres, it appears in version 7, and basically both databases are protects each entry which is made through transactions log. It should appear in the log first, prior to the changes in the database will be implemented. Unfortunately, if you're using archiving of logs, this option will be switched off because of Linux core. Unfortunately, this is how it works. Postgres writes the log in segments of 16 megabytes size, and starting from version 10, it's called PGWall. Prior, it was called PGX log. In Oracle, when you create a log group, you need to indicate log group with one or more files in which group, and this is where the transactions log will be written in Oracle. So basically the principle is very similar, and both databases support archiving of data log, and unless the segment is not archived, database will not accept new changes in the system just to ensure the condition of the archive. Undo. Version of the database, as I've already mentioned, Postgres ensures that in bulk writing, and if you're doing update in Postgres, basically new insert of a new entry is created and old entry is deleted. And if you're making update of entry, you have two references in the index, one for the older version and one for the newer version. And if there are many updates for you, the entry will be just one, but in physical table or index there will be many references to the older versions. To clean them up, Postgres has process which is called vacuum. This is something that exists only in Postgres. Oracle doesn't have such feature, and our recommendation is to set up vacuum as aggressive as possible, because if vacuum will not be on time, you will have problems because your indexes will grow, and many problems will emerge because of that. And in Oracle, it's realized on the level of blocks. When you update an entry, Oracle just takes a whole block and copies it to undo area. This is why index contains the most up-to-date version of the entry which you're using. If there is a request for older version of data, for example, when the table is constantly changing, it will see that in the table the version is too new, and it will go to undo for older version. Unfortunately, Oracle has such a feature that if your transaction which changed a lot of data needs to be rolled back, Oracle will have to copy into undo file, and it takes a lot of time. When long transaction fails, it's quite inconvenient. Oracle also have another function, flashback query, which enables you to, for example, if you delete half of customers by accident, you can fix it. You don't have to take backup immediately. You can take SQL features and get the data from there. It depends on the settings and size of undo segment, and this is a very convenient feature. Currently, there is a patch or extension which can perform this operation, but I wouldn't recommend to use it. I think a few people in the subscription told me that they want to do something similar.
Backup and restoration. Actually, both databases are available for hot backup. It means that you do not have to stop backup, and they also support point-in-time recovery. But Postgres is different here. Unfortunately, when this function was added, they accepted the following paradigm. They said that the database should not know that it is being backed. So in order to archive it, the database provides you with an option in a file with a configuration where you write a line, shell or utility, and it will be responsible for the transaction block segment being present in the archive. And the database doesn't care how you will do it. Backup is similar. There are two functions that make it possible for you to use backup and finish backup, and the database does not know how actually backup happens. There are several utilities that can be used for backup management and for backup removal. They make it much easier for you to work with backup, but actually everything that they do can be done manually. In Oracle, everything is much better. They have the following feature. They have Arman. It is integrated into the base. So the base knows that it is being copied, it is being backed, and you have a lot of opportunities to restore the whole base or a specific table space, specific file, or a specific block in this file. If you are conducting a verification and the base says that this block was damaged, you can take this block from the last backup and after that add all the necessary changes into it. Arman is integrated into database, and block change tracking is supported here, so the base can track what blocks were changed after the last backup. It means that you made one backup of your database, and after that you can conduct incremental backup of your database every day, and it's really very convenient. And transportable table spaces are supported as well. It means that you can take any table space, copy data files into another database and connect it there and continue working. And starting from version 12, these things may be conducted with the bases themselves. It means that you can disconnect the base from the example, copy it into another place and start operating. So it's much easier to manage databases and data, preservation and active data guard. It is similar to host and bar in Postgres and real application cluster. It is not a complete reservation because in the whole RAC instance there is one common data medium. Oracle also provides such function as flashback query. Also, you can conduct flashback for a table of the database. It's very convenient in particular, Well, in my experience, we had very critical and complicated migrations, and before the migration started, we initiated flashback database, and then migration took place for several hours. After that, we disconnected flashback and had our migrated data, and if something went wrong, within 10 or 15 minutes, we had to return database to the point before this migration began, so we did not have to restore the database. And Oracle has similar technologies, just like change data caption, streams, and Golden Gate. The first two of them are considered to be outdated. They are quite similar to Postgres logic wall decoding. So transaction log is read and it is decoded into SQL statement that can be filtered and brought into a different place. So that's everything that I wanted to mention. In my opinion, Postgres has a lot of potential for the improvement, and in my opinion, the priority is the improvement of tools for monitoring, because it's quite difficult to monitor queries, especially long queries. I also want to have pointed time recovery for table spaces and databases, so that some base may be removed from cluster and placed in a different place. And I also want the base to realize that it is being backupped. Maybe provide backup slots. In that case, we'll be able to conduct incremental backups, and the work of system administrators will be much easier. If you have any questions, I will be very glad to answer them. Thank you for your presentation. I have the following question regarding MVCC. In Postgres, is it implemented through the addition of data and the cleaning of old rows through vacuum? And in Oracle, it is implemented through underlog. Are there any other options of MVCC implementation? Maybe other vendors have them. And if now you decided to create your own database management system from scratch, what option would you choose and why? It's a very interesting question. Speaking about other options, well, there are typical locking systems, but I cannot consider them as serious ones. And most of them follow Oracle. Most of version systems follow Oracle because it's the oldest system. What would I do? Well, it's a difficult question. Well, there might be some problems with PostgreSQL, but if I manage to set up and control everything, then it will be quite fine. I have never had an experience when auto vacuum was #1 headache. So we managed to set up auto vacuum in a qualitative way, and it was quite okay. And also we needed other measures. We had to monitor transaction load, we need to monitor long transactions, and so on. And if I decided to do everything from scratch, I would like to have a combination between the things used in Oracle and in Postgres. I think that undo segment is quite attractive, but not the way it is in Oracle. Maybe it should be a bit different. For example, Postgres has chain step. So if no indexed column is changed, then Postgres may provide a new version of entry into the table block, but the indices do not change. So if we have it in a separate space, that would be really good in my opinion. And we need to continue using hint bits in Postgres, because in that case we will be able to avoid problems. In Postgres it's quite easy. You just insert hint bits and that's it. So we do not have to transfer big volumes of data. Could you assess these databases from 1 to 5? Functionality, convenience, 5. Hello, my name is Alexander Pakratov. I'm from Paros company. I have a rhetoric question regarding temporary tables in Postgres and Oracle. I think that in Postgres, temporary tables are common files on drives, and they are to be created within one session. So if we imagine that there may be 100, 200, 300 physical sessions, and every session will need 100 or 200 tables, then there will be so many files on the drive. And how quickly will the file system and DBSM work in that case? Well, it will not work fast. And in this case, we will need not to use the file system that works faster, but talk to the developers. Why do you need that many tables? So we do not use temporary tables so often. Maybe you try to transfer the functionality into the database, to use it as a waste bin, and in that case productivity will not be good. I would like to add something. Postgres has a setting, max files per process, so the number of opened files. By default, it's 1024. If you have to open a lot of tables, then Postgres starts reopening files, and if there are many files in one directory, then the productivity of file system suffers. So you can raise this limit. Thank you for your presentation. My name is Mikhail. Could you please comment on the monitoring of complicated queries? So what tools we're speaking about? Extension or application? Well, that's about functionality of the database itself, because today, if you have a very heavy analytical query for 2 hours and you can monitor the load in operation system, but you cannot see any other meters in the database, so you don't know what is doing there. In case you have Oracle, there is a special mechanism. Even if the query is not finished, you can see what this query is waiting for a drive, for the network, and so on. And there is another system view, where in case of a long query, you can see what stage it is on now. And you can connect it with other system views. You can see its execution plan and see how much time it has to work. Postgres does not have such a tool. Well, the work in this direction is underway. There are people who work with production system in real life and they really need it, and people responsible for the development, and quite often the main problem is to persuade them that this functionality is necessary, because this functionality may result in a small performance degradation, and we are to persuade them that it is really necessary. Hello, thank you for your presentation. Could you please briefly describe the work of optimizer for both database management systems? The Postgres is a better one because Oracle is really a big system. It has much more functions, and quite often it has to select one option from many options, and that's why it can be slow. But modern Oracle version 12 can work in situations when there is no statistics much better than Postgres. Well, these are different systems. Oracle is more expensive. It has more money. Thank you. It was interesting.